Okay, so we have discussed till question number 6. Now today we will discuss question number 7 onwards. So in question number 7, the very first question is we have to simplify 2 upon 5 to the power 7 divided by 2 upon 5 to the power 4 into 2 upon 5 to the power minus 2. Okay, so again we will use the property of exponents, that laws we have studied so far. So what happens, this is division sign, so these powers are going to subtract with each other like this, into 2 upon 5 to the power minus 2. So it becomes 2 upon 5, 7 minus 4 is 3, into 2 upon 5 to the power minus 2. Okay, like this. Now next, since this is a multiplication sign, so finally what we will get, we will add the powers, 3 plus minus 2. So it is 2 upon 5, 3 minus 2, and the answer is 2 upon 5 to the power 1. Okay. Then suppose a question is like this: 3 to the power 0 minus 2 to the power 0, and its power is minus 5 divided by 7 to the power 0. Okay. Now what I have told you, any number whose power is 0 is always equals to 1. So it is 1 minus 1 to the power minus 5 divided by 1. Okay, so this is 1, this is 1, and this is also 1. So what we will get, 0 to the power minus 5 divided by 1. And if 0 is carrying any power, then in that case, okay, if I write its reciprocal as this, and it is into 1, so its answer is not defined. Okay, there cannot be, the 0 cannot carry the power as negative, so its answer is not defined. Okay, then in fourth part, a different type of question is there: a to the power minus 3 into b to the power minus 4 upon 3 to the power minus 5 into a to the power minus 5 into b square. So see, what we will do, we will write the powers like this: 3 to the power minus 4 minus, since 3 to the power minus 5 is in denominator, so we will subtract the powers. Similarly here also we will subtract the powers, and similarly here also we will subtract the powers. So what we will get, minus 4 plus 5 minus 3 plus 5, and it is minus 6. So our answer is 3 to the power 1 a square b to the power minus 6. Or if you want to take the reciprocal, you can take the reciprocal. The exponent of, after doing the reciprocal, the exponent of b becomes positive. Okay, so whenever you have the powers in this form, okay, so whenever you have the powers in this form, like in this case, so you just subtract the powers, because it means 3 to the power 5 is divided by 3 to the power minus 5. Similarly, in fifth part, it is 3 to the power minus 1 minus 6 to the power minus 1 plus 2 to the power minus 1 minus 6 to the power minus 1. Okay, now as I have told you, whenever it is minus power, so what we will do, we will do the reciprocal of this. So it becomes 1 upon 3 minus 1 upon 6 plus 1 upon 2 minus 1 upon 6. Okay, do not multiply the power with the number. with the base. Okay, it's already been told to you. Now these are the two fractions. So first fraction we will take the LCM. 6 is the LCM, 2 minus 1. Again here also 6 is the LCM. So it is 3 minus 1. So what will be our answer? Our answer will be 1. So our answer will be how much? 1 by 6 plus 2 by 6. And since the denominators are same, so it will be 3 upon 6, and when we solve we will get answer as 1 by 2. Okay, so these are the 4 different type of questions in which we have used a different properties. Here we have used the division and product rule. Here we have used the concept that anything raised to the power 0 is 1. Here again we have used the division rule, but this is written in terms of fraction, like fraction, and here we have converted this minus 1, that power, into the reciprocal of the number. So question number 8 is like, so if I see the very first part, it is a to the power x plus y minus z, dot means multiplication, x minus y plus z, and whole power is y. Okay, so here this dot means multiplication. Now bases are same, so we will add the powers, x plus y minus z plus x minus y plus z, and whole power is y. So this y and y will cancel, z and z will cancel. We will get a to the power 2x to the power y. Okay, like this. Again we will multiply these two powers, so our answer becomes a to the power 2xy. Okay, then in third part, again we will use some concepts here. 5 upon 7 into b upon a to the power minus 5 upon 7. Okay, so like I have told you, see, neither the base is same nor the exponent is same, but we can make them same. How we can make them same? We will do the reciprocal of this, like I have told you, and when you do the reciprocal, this power becomes positive. Now see, both are having the same base. Now we will add the powers because they are multiplying with each other. 5 upon 7 plus 5 upon 7. So our answer is a upon b 10 upon 7. Part 1 upon 4 to the power minus 3 minus 1 upon 2 to the power minus 3 upon 1 upon 8 to the power minus 3. Okay, so what we will do? We will do the reciprocal of this, so it power becomes positive. Here also power become positive, and here also power becomes positive. Okay, while taking the reciprocal, it becomes 4 upon 1. So 4 upon 1 is 4, 2 upon 1 is 2, and 8 upon 1 is 8. Now we will solve the powers like this. 4 cube is 64, 2 cube is 8, and 8 cube is 512. So it becomes 56 upon 512. So it is 8 into 7. Answer is 7 upon 64. Okay, so like in this manner, you can solve the questions by using the laws of exponents. So this is the end of this exercise 4.1. Next we will study about the new concept in this chapter, that is exponential equation. Next is that we will be studying now exponential equation. So exponential equation is bases are same on both sides, then equate their exponents. Okay, the concepts behind this solving the exponential equation is we have to make the bases same, then we will equate the exponents. For example, suppose if I write 2 to the power x equal to 2 to the power 3. So here the bases are same. This is very much clear. At LHS it is 2 and RHS also 2. So what we will do, we will equate these. So x becomes equals to 3. Okay, so this will be the concept that we will be using to solve any exponential equation. You have to make the base as same on both the sides. If the base becomes same on both the sides, then you can easily equate their exponents. Okay, so let's see the exercise 2.2, question number 1. It is minus y upon x raised to the power minus y and x equals to minus 1 and y equals to minus 3. Okay, so in this we will simply put the values. So what is y? It is minus 3, x is minus 1 and here also minus 3. Okay, just simply put the value of y and x. So see what you will get, minus plus minus 1 and it is also minus plus. So it is actually what we get, minus 3 cube, and minus 3 cube is minus 27. Then okay, 2.2 exercise we are solving. Then for the third part, it is x upon y to the power x into y upon x to the power y, and x equals to 4, y equals to minus 7. So here also we will first put the values. So it becomes 4 upon minus 7 to the power 4 into minus 7 upon 4 to the power minus 7. So now we will make the bases as same like we were doing. Okay, this minus sign we can write anywhere, and we will take the reciprocal. Okay, when we take the reciprocal, what happens? This negative exponent converts into the positive exponent. Now this is minus 4 upon 7, 4 plus 7. So our answer is minus 4 upon 7 to the power 11. Okay, so whenever you have the negative exponent and if you want to solve it with the positive exponent, then you first convert it to make the bases same on both sides. Now moving on to the question number 2. In this we have to solve the exponential equation. So we will keep the concept in mind that in order to solve the exponential equation, what we will be doing? We will be making the bases as same on both the sides. Like for the very first question, it is 128. Okay, so now base here is not same. It is 2, it is 128. So we will do the prime factorization of 128. So it will be 2 into 2 into 2 into 2 into 2 into 2 into 2. Okay, like this. So what it becomes? See, 2 to the power 7. Now we will equate the exponents. Okay, since bases are same, so we will compare. Okay, we will compare the exponents. So what you will get? X equal to 7. Then suppose we have to solve a question likes of this, root 3x, root 3 to the power x equal to 27. Okay. Now see this root 3, as I have told you, root 3 we can write it as 1 upon 2. Okay, root 3 can be written as 1 upon 2 equal to 27. So now powers will multiply with each other, x upon 2, and this 27, okay, this 27 we can write it as 3 into 3 into 3. This we already knew. So it is 3 to the power 3. Now again their bases are same. So we can say that x upon 2 equal to 3. So what is our x? 3 into 2, that is 6. Okay, so like this we can solve the exponential equations. Then let's see one more part, a different type of. Suppose if you encounter with these type of questions, okay, 7 to the power x minus 1 equal to 1. Okay, now we cannot do the prime factorization of 1, that's we know, but we have to convert this RHS into the same as base of 7. So as we know that if I write anything raised to the power 0, its answer is always equal to 1. So I have written in 1 in this form, 7 to the power 0. Now we can say that equating the powers, when we equate the powers, we get x minus 1 equal to 0. So from here x will be equal to 1. Okay, so whenever on the RHS you are having 1 and on LHS only one power is there, only single base is there, so you just convert that 1 into the power of 0 so that it will give you the same basis. Then suppose it is 11x to the power 2 equal to 1 upon 1331. Okay, now so here what we will do, first we will multiply their powers here, and this 1331 we can write it like this. Okay, this we have already studied now, so it becomes 1 upon 11 cube. Now since we want the base is 11, here base is 1 upon 11, so I will bring this 11 in the numerator, and when I bring the 11 in the numerator, this 3 becomes minus 3. Okay, we know that whenever there is a reciprocal, the sign of the base, the sign of the exponent always changes. So now we can say that 2x equal to minus 3 and x equal to minus 3 by 2. Now the questions likes of question number 7. Here we have 2 terms on one side and 1 term on the other side. Minus 4 equal to 4 upon 11 to the power 3x. Okay, this is our question. So what we will do? See, first of all here the bases are same, so we will add the powers. Minus 5 plus minus 4 equal to 4 upon 11 to the power 3x. Then it becomes minus minus plus, so 4 upon 11 to the power minus 9 equal to 4 upon 11 to the power 3x. So finally what we will get? We will get minus 9 equal to 3x, or x equal to minus 9 upon 3, that is minus 3. That is minus 3. So minus 3 is our answer. So again we have used the laws of exponents when the bases are same. So like this you can solve the exponential equations. Try to make the base as same on both the sides. If the bases become same on the both sides, then you just equate their exponents. So that's the end of this exercise 2.2. Next we will discuss the standard form of small numbers. Thank you.